Oh boy. Welcome back. Hello. How you doing? Hope you're great. I'm Agent Ultra. I'm here to code in Haskell today. Thanks for joining me. I do these streams about once a week, and we're going to dive right in. What do we work on tonight, though? Well, we have this interactive fiction engine we've been working on, or I can do something else. What do you think, chap? Hmm? Well, let's see what we got here on our adventure getting. I think we were working on the parser. And there was an experiment we were working on for, yeah, a couple of different approaches we wanted to try there. So let's look at some of those. I'm gonna fire up my editor. It's gonna resize a little weirdly. There we go. Okay. So our to-do file here. So we're on 214 there. We're trying to validate room IDs in the exit section parser. That was looking pretty good-ish. Source maker parser. Okay. So if we go to the world parsers, this is the file we're trying to generate here, the world. All right, we have this dependency on, first we bind the world room. So first we parse this out of the file. And so this has to be the first section of the file at the top of the file. Then we parse the world exits. And that's the second thing we have to parse. So this has to come immediately after world rooms. And the things that are good about this are that world exits section parser can know that the room IDs are already in the parse state. And so when we're parsing the references to the different rooms and the exits, all right, it seems sort of natural that we can also check, are these references to these rooms, do they actually exist? Are these rooms actually defined? Right, so we get this exit ref parser here where we can fail if the room ID is not defined, check the room section, go over there, see if you did the right thing there. Otherwise, we parse it and everything's good, right? So that when we load this world file, it should be a valid world file. Like all of the IDs are used consistently, which is a good thing. But the one drawback I think to this approach is that the format of the file is like pretty strict. And a little bit different than what I had intended when I first started out on this adventure here. Originally, I was kind of thinking that this would be more like a section file format. Or like an INI style-ish format. Where you put the room section, the exit section doesn't really matter so long as you have the sections in there. It should be all good. So this file looks like this. An example adventure world.txt. All right, so we have to have rooms, have to have exits next. So I was thinking originally that you could define this exit section and this room section in any order in this file that you want. If you prefer to put the exits at the top, good on you. Shouldn't stop you. That just means that we can't depend on, when we're parsing the exit sections, that the room IDs exist. All right, so we would parse these things out in an arbitrary order. And the final step would be to run through and validate the data structure that we generated, the world we generate. All right, so we'd run through the world, And we go through each of the world rooms and check their exits and make sure those exits exist and those objects exist. And then we'd run through the objects and make sure, well, they might like refer to verbs or something. We could check that those exist, right? Exits, we'd check all the room IDs exist and things like that and so on and so forth in a separate pass. And that way we can kind of separate out those two things, which would be super nice. Right, otherwise we have to have an error message for this dependency. Like the user has to know what order it goes in and all that sort of stuff. We have to report it when they don't do it right. So sometimes when I'm kind of at a design impasse and I don't know which the better approach is going to be, I just make a lightweight branch and try it out. Try out the alternative. What would the alternative look like, right? So if we look at the project, git history, after master, we add the exit room ID validation to the exit parser and then validate the entity refs on the exit parser. So we should be able to branch from master again and do our changes there like we did here. And then we can kind of compare our results. Yeah. Okay, so let's try that. I think that's a good idea. I'm going to check out master. I'll create a branch from it. And I'm going to call this one... What did I call the other one? Experiment incremental validation. So I'll call this one experiment final validation. Okay, so our success with this project, this experiment here, will be that we can, one, parse either section in either order in the file. That'll be condition one. And the other one will be that we can validate the references still and get the errors to show up at the right place, like we did with the other branch. Okay. So I think what I'm going to start with when I go down this path is the first one, making them parsable in any order. So I want a parser that's going to run through the whole file and get every section that we have defined and return a list of sections. Yeah, that should be fine. And then each section, we're going to need to know which sections belong to which part of the record here. So it's going to be a list of the section names and the data that we parse. Well, because each of these exit parse, like this, we have to just know, we know that this exit parser goes in this field here because we bind it to a variable, right? And if I do this parser where we can just parse whatever section, if we just do the data, we lose the name binding. All right, so what field it goes in, which would be no good. So yeah, section parser would be a parser of some text. And let's not make it text. Let's make it, let's use a type. That'd be smarter. That we can pattern match on it. Section type. And the section data. We can't really say what kind of entity ID it is or entity that we're parsing here. But the names, the symbols are the same, so we should be able to replace those with a generic type variable there. Leave it undefined for a moment. So you don't like that because the... Ooh, we already have defined a section parser, right? Yeah, sections. Difference of one letter, but hopefully it makes sense. And define the section type here. And we'll just give it an equal eq and show. Yeah. Okay. And then we need from text. Or section. So that'll be text to section, maybe section. All right. Wait, new type isn't right. Nope. We need a data type. I want something like that. I want room section, exit section. And then you can show here. Yeah. This should be good. What's the problem? Oh, maybe. Right, because we can't match all strings, of course, all text strings to values of our type here. We'd have to do maybe. We can get rid of the maybe if we have like a bucket type here. Unknown section. And that would be okay too. Unknown section. All right, and then when we're pattern matching on this section constructor after we've parsed them all, if we come across an unknown one, we're like, what did you define here? I don't know. And we can put a type error there. We don't have to show that there's an error by returning maybe, right? So that seems nice. Okay, so now we can parse sections. Oh. So I think one thing we need to do with our exit section parser and our room section parser is to return the section as part of it. So the return type will be section, list of section data. And this is not going to quite work here. That's okay. What we can do is bind it. And then return the from text of exits to section data. Hmm. 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 And if I get rid of that there, no, no, this doesn't feel like the right place to put that, actually. I'm going to revert this. I think section parser can handle this. Yeah, and then I'm not repeating myself here. And why does it like this? What did I do? What did I do? Could match could match a function type, a parameter. Oh, from text. That's right. So yeah, section name can go in here. There we go. Yeah. So then we're not repeating ourselves there, and that should fit all nicely in together. We still, of course, got to fix a few things with this. A couple more type errors to get this to slot back into place. Okay. So I'm going to ignore those for now because we're going to get rid of them. But we have the sections parser now. So how are we going to do this one? We could do, well, let's see. We could do set by. Set by only lets us take a piece. So we'd have to have several section parsers to try, basically. So I think one of the other things that's, if we do it this way, that's going to probably not be a huge problem, but it's a bit of a trade-off, is the backtracking performance, right? If we do like to do this, we can just define the sections in any order you want. It means the parser has to try one of many alternatives every time. All right, and these parsers are, they can be pretty big. I don't suspect it'll be an issue though, but if you're doing a really big file, it could be. You might want some kind of streaming at that point. But even then, backtracking is not going to be your friend there. So, things to consider when parsing data. So maybe this won't be the thing, but we're gonna make it work first, and then we'll compare and see what we like better. Okay, so we could do set by basically. Set by 1 would be a little bit more strict and require at least one section, but we're going to end up needing all of the sections, of course. We can't just have one or two of them. So that's another validation step we're going to have to make at the end after we've parsed all of these sections, is do we have the right numbers of them, the right ones, that kind of thing. So let's try set by. What are we going to separate it by? What's going to be our sep parser? Right? We have our parser. We don't know what that one's going to be, but what is our set by one going to be? New line. Yeah, we're going to need or world sections, we call it. The world sections, a parser. Basically, I think it's basically going to have the same type as the more generic version. How's our sections parser? Okay, so in order to implement this, we need try. And then we're going to try room section parser or exit section parser. Yes, this is going to be a tricky thing. So this type error here, and I'll means that we're mixing up the A's here. Because we said these A's have to be exactly the same, we've said nothing else about them. All right, they don't have to be A-like or sort of like this thing or have something in common. There could be many such A's as long as they have something in common. Like it's strictly, these can be one type of thing. So we're getting this type mismatch error here because of that. So one way around this is we could define some kind of type class that makes them thingy-like, so that we can invite more than one type into the family of A's here, into the set of A's. All right, it could be like has thingy. Right. And then as long as each type that we're trying to parse here from our section parsers implements an instance of this class, then they become things that can be A's in this type signature. Which, yeah, I'm not super stoked about. So, yeah. Because, yeah, when we make this list of sections data, now we kind of need some type of, I forget the term, but it's it's pretty common in a more loosely typed languages to have lists of different thingies, all living in the same list. Heterogeneous lists. Yeah. So we want like non-heterogeneous lists. It's kind of what this is going to do. Is it worth the effort versus the other approach that we've been taking, where we explicitly bind them out, then we don't have to do this type nonsense? Yeah, you know what? Let's. This doesn't feel like it's going to be worth it. So it was a good experiment, but I'm going to call that and just say nah. Sure, save it. Okay. Okay, so we'll switch over to the incremental validation. We'll get rid of final validation. Bye-bye. Okay. This is okay. This is fine. So we'll just make sure, like, when we tell the user how to write this file, that they just have to do it in the right order. And maybe we can even throw in like a little tool into Maker to like spit out a template file that they can just start filling in to make things, to get them started quicker. Yeah. So let's just put this in master. Let's just merge this. Okay. Okay, so that's good. Let's go to our to-do file. So then, since we're done that one, now we need to, what else do we need to do? Let's check. We need to check source. Let's look at the engine. We need to look at objects. Yeah, so we have room. We need objects. That's going to be a big section. Yeah, this one. Okay. Okay, so world objects. It's going to be object section parser. And it's probably going to look just like the other ones. From list, world objects. Okay, so done that. We can do object section parser here. Section parser of objects. Object parser. Now we need an object parser. Object parser. As a parser, it's going to return an entity ID of game object and a game object. All right. Game object. This is going to be an interesting one. Object parser. Okay. So we need an object name, a description. We also need the entity ID of it. Hmm. Hmm. Okay. Object parser. Okay. So, sorry, I was blanking out thinking there. um, right. So the object parser is going to define where all the objects are. What I was thinking about was the rooms. The rooms have references to objects, and I'm thinking about validation. All right, so exit parser is kind of lucky that it came after rooms because it just talks about rooms. All right, so as long as all the rooms are defined, we're good to go. Objects, rooms can talk about exits and objects. Right, it has space for defining both of those things. And so, if we want to validate that the room's object references are good, we need to have some kind of validation step. And we need to do that either. Let me leave this undefined for a second. Right, if we do world objects after world rooms, We either need to do that validation while we're parsing object section parser, like after we've parsed all of the objects, we can do a validation step before returning this parser. Or we have another validation step after, like here. Room object references. Or, that's one way we could do it. Or we could do objects first. Because objects, I think, only refer to other objects. They don't refer to rooms or exits. All right, so game object has a name, a description, and an object. An object is either an item or a container. If we have a container, we have references to other game objects, container locks, and items. We just have items. They're just so far, size, await, and some verbs. So they refer to verbs. What do verbs refer to? Verbs, I think, are just special bits of text. It's not defined in here, I don't think. Yeah, verb. Yeah, it's just a wrapper around some text. So it's just some special text. So we could even make sure that verbs come first. Since verbs don't refer to anything else, if they come first, then we parse them first. And then we can parse objects since they refer to verbs. Then we can parse rooms since they refer to verbs and, well, since they refer to game objects and exits. And then exits, because they can refer to rooms. The only other thing is we have that circular kind of relationship with exits and rooms. So you'll maybe I'd abandon the other branch too soon. I was just thinking there might be a way to get the heterogeneous listing to work without too much effort. Which, yeah, trade-offs. Because then we don't have to worry about the order so much. Yeah, because if we do get rid of the order, I don't know if this is important or not, really. To be honest, I'm probably spending too much time on it. Okay. So the world objects. Objects first. Let's do it. Okay. Object section parser needs the object parser. So how are we going to define what this looks like? Actually, let's go back to undefined. Let's go back to our text file here. So after we have, we're going to have game objects first. Right. This is a pretty nice pattern here. Let's be consistent. So we can have a Baz. It looks a little rubbery and wet. Yeah. What is the Baz? I don't know. But it looks a little rubbery and wet. That's what it is. So in here, we already have the game, the entity ID, of course, the name, and the description. We don't have the object just yet. That's going to be a little trickier. So if we want Baz to be just a regular item, how are we going to fit that into our syntax here? We could make like a little tag here, maybe. Maybe. We could do like a property. Type, item. That's probably cleanest, and we can reuse a fair bit of our parser for that. Not bad. Okay, so what do we need to fill in an item? We need a size, a weight, and potentially some verbs. Something like that. Do we kind of have any other examples here? Items, objects. Yeah, so we can make up another one just for funsies. We can call it a bar, long steel bar. It's an item. Its size is, I don't know, 4. Weight is 12. Verbs, black. Okay, I think that's pretty good. We should be able to parse this. Let's go for it. So we're going to probably need like an item parser or a container parser. Um, How to structure this? well, all game objects, we have to get the things. So let's do this thing, let's get the hash mark, octothorpe, whatever you want to call it, space 1, and the, call this game object parser. Yeah, that's better. Game objects. And game object ID. Game object. Well, I'm going to capitalize that there. Noticing a mistake here. That probably should be an H space. I don't know if there's an H space 1 function, though. Maybe there's. Hopefully there is. Okay, another H space 1. And, or maybe just an H space. H space 1. Yeah. And the item name. Or game object name, I guess. Would be a non-empty line parser. Brilliant. Oh, we don't need to do any of that. So after we get the object name, then we can get the description. Yeah, so we consume an H space, a new line, I suppose, right? After this, I think that consumes a new line, yeah. So we just gobble up all the text until thing. So game, object, description, many till, line parser, single, octothorpe, hash, bang, whatever. There you go. And so we'll get that description there. And in fact, we'll follow our convention, desk lines. Yeah, okay. Then we take a new line out. And now we're in our properties. So this one is kind of like going to be our sort of discriminator, right, on what kind of game object we're parsing here. So there's a chance for this parse to fail if we get this far and this isn't an item or container. So let's see. We got some property list parsers, a property list parser 1, property label parser. So I think we need like a property sum parser or property enum parser. That might make some amount of sense to someone in the future. So the idea is that we need, so in order to implement this, let's put it down here. Property enum parser. All right, we need a text for the label. We need the enumeration we're supposed to be parsing to. A parser for it would probably be the best way to do that. And then we return a parser of that. A. And so the idea is that you give me a parser for that enum p. We'll run that parser, and if it fails, well, then we have a parse error. Otherwise, we return the value of the enum it parsed. I think that'll work. So first, we do the property label parser of the label. And then our enum is the value of running the enum p. In fact, I think we just do that. Yeah. Don't have to bind it. Okay, and so then we need to give that enum parser in order to use it with game section parser. Or sorry, the game object section parser, the game object parser. To that. So section or game object type property enum parser, and we're going to need a item type parser. Okay. Our item type parser is going to be a parser of our item type. We need a type for that item type. And it'll be or game object type. It's either an item type or a container type. And having type in the name of a type would make discussions about this type a little difficult. So call it kind. And kinds is also another Haskell keyword. Let's not sweat the small stuff. Let's just leave it as type. If it becomes a problem, we can always refactor it later and stuff. Okay. So I'm going to change that to game object, though. Okay. So how does this game object type parser work? Well, it's going to eat up all of the non-empty text, some non-empty amount of text. And And then we're going to pattern match on the text that we get back. So non-empty line parser, non-empty line parser, line parser. Non-empty line parser by, and we'll give it space. I think that's what we'll do. So we'll do type name, non-empty line parser by, and we'll do space. So space covers horizontal space as well as new lines. So this is going to consume the new line, which we might not want property enum parser to do. But I think many-till consumes that last character. Oh, we want some till to get up to the end. Note that the end result is consumed and lost. Oh, but some till underscore keeps it. Okay, cool. Okay. That will be nice. So yeah, so that we can have the new line here. We'll have to bind it, and new line. And return. Okay, and then we have to fix where we were. Type name. So non-empty line parser by uses some till consuming. So we can follow a similar convention, I think. Make a new helper for this, where we put the underscore in, so it uses some till underscore. And that way, we can just use, yeah, we can use space here freely. And not worry about consuming the space. No, we can use new line here, even better. And we need a game object type. So now we need to case match on the returned non-empty text bit. So the only valid ones are item, which should go to item type, and container, which will go when we implement it, container type, and boom. Oh, sorry, chat. Senkomoon. Can you ask a question about time management? Well, as long as it doesn't take too much time. Yes, you could. What's up, Senkomoon? What's your question? So otherwise, we're going to fail this. invalid game object type. In fact, we can probably append to the message the type we got. Invalid. Sorry, Sengomin, but yeah, let me know your question, okay? I'm curious. All right. So we got item type, container type. We can parse that. We're good. Okay, so we have the game object type now. We need our other properties. We need the size and the weight. So wouldn't I be able to... Oh, right. We need to case match on the game object type here. Yeah. Game object type of. So we have an item type. We have to do something. And if we have a container type, we have to do some other properties. For now, container type, let's just fail and not implemented. But for item type now, we just need a few more properties to fill in. So we can go the item size. And what I was thinking was that property enum parser like doesn't really say anything about the A. Just it's a parse of A. So if we had like a num parser here, that would be fine too. So maybe enum parser isn't the right name for this. So let's put num parser in here. Do we have one defined in? It's a pretty common parser to implement. So I'm wondering if text, megaparsec has it. New line, CRLF, EOL, tab, space, H space, H1. So they do implement digit car. It's not too much of a stretch to get an int parser. So they have a string, but no int parsers. We might have to implement our own, perhaps. These are all just combinators. So we might have to, an int parser isn't too bad. All right, so we got item size, item weight. And verbs. And that would be a property list parser. That could be empty. And so we'll need a verb parser. And then once we have all of this data bound, then we can return a constructed game object. Or object. Yeah. which we'll bind. So this has to return our object item of the item. Pull this over the left a little bit so we can go here. We could do item size, item weight equals item weight, and item verbs equals item verbs. Just like that. Yeah, it's not a scope for some reason. What did I call it? I put ticks on them for some reason. Okay. And then once we have the game object, then we return here game object. And so with game object, we have the game object name. Game object description. And we have to construct that from the game object description lines. Unlines? Do we have an unlines? I think we've been using unlines. Maybe not, but hopefully. Game object desk lines. And game object object? Something like that. Game object object. JavaScript. Okay, so almost complete. We just have to implement these int parsers and verb parsers, and that should be good to go. Okie dokie. Int parsers. Let's do that one next. Have I been... I kind of putting little helper parsers up here. Let's put int parser after entity ID parser. Okay, so we want digits. With many till underscore. We're going to use digit car and anything that is not a digit. Or any kind of space character. Yeah. Yeah, it might work. Okay, so that's int parser. Then we have object. Hang on. Verb parser. A parser of verb. So we can get the string just like we do for non-empty line parser. It has to be some amount of characters. Except we don't necessarily need a line. Um, to end it. Hmm. Manytil underscore line one car, but what to put there? Um, oh, I wonder if Lexer has anything. Space, Lexium symbol. More programming language type parsers called Lexers. We want to produce symbols, but anyways, or tokens. But let's see. We want alphanumeric. I don't know if we have any restrictions on what can be contained in a verb. We look at the game engine for verbs and language. It's literally just wrapping text. There's no smart constructor to it to restrict the range of text. We just basically use the new type to wrap it, and so we can treat it as a type. But what constitutes a valid verb in our game? I would say that it has to be some kind of letter character or lower car. It might be fun to have like whatever cased letters you want in there in case you want to do something funky with your script. But ultimately, in order for us to match on the verbs and such, I think actually we do full text match, maybe even. Uh, do, 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 do. So we take input from the user. We handle user. Let's user commands. Handle use. This is handlers. Big and handle take. Um, yeah, handle verbs. So like we lowercase them all here. And there's only actually there's really only we don't have any way to do user defined verbs yet. That's right. Because these all map to very specific handlers. It would be nice if there was, but I haven't figured it out how to do that. Figured out how to do that with this engine. So yeah, we might not even. So that actually kind of simplifies things, I guess, for our verb parser. So it's lower car. And we end at anything that isn't a lower car. So mm, how do we get it so that it's not whatever is not in this set? Maybe there's a combinator for it. Like basically the opposite of this parser. Um, yeah, like non-lower car. I don't know. I think I'm gonna try that non-lower car. Um, so assuming that works, we can implement that. We have a string. Then we need to case match on the string. It's one of our valid verbs. Which we don't have to power to match like that. We can just say if stir is an element of valid verbs, then pure verb of stir, else fail, invalid verb. And we'll combine that with the stir we got. Okay, so non-lower car. That's the only thing missing from that. Non-lower car, non-lower car. Parser. What do they call them? Tokens? I don't know what the type is. I'm just going to put something silly in there. I'll just make it int. Non-lower car is going to be simply something like if we get a value for r, we want to fail it. So we want to try parsing the next car. So almost want to write satisfy not is letter, or sorry, lower. Is lower. What did I do here? Multiple declarations of verb parser. Oops. Oh. Eh. Forgot that. Silly me. So verb's not in scope. Port adventure.engine.language. Is lower is probably not in scope. So I need import data.car for that. Oh no. I just want the stir part. So then we need a valid verbs in scope. And valid verbs. We'll just get from language engine. I don't know why it's defined an engine. Maybe that should be cleaned up. Plop that over there. Ooh, that's going to overwrite because it's a rectangle, right? Yeah. Walk. Pick up. Drop. Look. Examine and take. Dig and use. And that should make you happy, right? Right, GHC? Come on. And we're almost there. What's the problem now? I typed the type wrong. We're going to return pure. We're going to return that because we're in a do block. Right, we need the entity ID and the game object as a tuple. Pure game entity ID, game object ID, and G. Okay, and what do we got here? So let's see. This one here is we want a string for fail. All right. Okay. That one fixed. And then these. Okay, so property enum. Okay, property list parser is one. All right, it wants the label for that. Okay, so that's easy to fix. Verbs. Probably wants the same thing here, so the item weight. And size. And type. So int parser's still got problems because the way what read returns probably isn't right. This has problems because of the text packing thing. Okay, so digits here. Same thing. Manytil apparently returns a tuple there. And this one here as well. And what's the problem here? Non-lower car is probably all over the place because it's not int. It's M0 token, which I think is going to be parser token text. Does that make sense to you, GHC? Actual type bool. Oh, Satisfy. What type of thing do you want in there? Satisfy? Function from car to bool. Right. So, oh, I wanted the composition. I was probably missing the composition operator in there. There we go. And what else we got here? So that needs to be, pack that into a text. I already have that. Jeez, stop asking me. My editor's starting to lose its mind here. GHCI is probably in a weird state. Ooh, maybe it's over here that's the problem. And then one more here. Okay. We expected a tuple verb, actual verb. Right. In the case of items, in the game object, in the item, the verb is a verb map. Let's. I'm gonna leave item verbs out for now, and we'll hard code it. So just the empty list. Because that's what allows them to define verb aliases. So it's not that you can't define verbs. You can define aliases, but you can't define like new verbs. Unfortunately. Right. Yeah, like dig had to be hard coded in there, for example, even though it might be like a verb you can dynamically add to the user by picking up an item and that kind of thing. So, all right. That's there. Type errors. I think we're good. Some duplication. That's just linting stuff. Let's see. Yeah, I'm not sure if I'm ready to do that refactor here. So we'll ignore that lint for now. It's just a thing. Okay, so objects, we should now be able to, get rid of that. Open up the world.txt file. And I think we should be able to parse this. And, oh wait, we need to world parser. Yeah, okay, we already hooked it up to that there as well. So yeah, so when we compile this and run it, we should get it should parse, I think. It might not, but I'm like 80% sure it will. Okay, adventure maker, data example adventure, right? Oh, we got it unexpected. Okay. So we do have a little slight bug here. And it's on size, so I think it's our enum doohickey doing a thing. So that's a bad name for that. We should fix that. Enum p. Yeah, it's just property parser. Let's get rid of that. And replace it. Property enum parser with just property parser. And I think the reason why it was originally failing is the type thing. The game object type parser. We just need the underscore version. And I think that now I'm back to 80%, which should work. Ah, no. It did not. Okay, so sumtil isn't working quite the way I had hoped it would. Perhaps. Or I'm not using it right. Sumtil underscore p end works similarly to manytil underscore p end. But p should succeed at least once. Use sumtil if you have no need in the result of the end. Right. So why does it return end? Oh, so end. Okay. Yeah. Rats. It isn't working the way I thought. So yeah, end is the bit that returns from end. So it's not lost, but the parser state is still consuming that and moving the parse state forward past end. The maybe we should try this. Many. I don't have a lot of luck with many because it seems pretty. And sometimes it makes my parsers get stuck. Parsing to infinity. But it might just be what the doctor ordered in this case. So might not even want this one. Oh, there's got to be a type error for this. Come on. Yeah. There it is. Yeah. Yeah. Okay. So type name. many. I think it might even do letter car. There's a problem with this. Yeah. So control.applicative has a many. So when we have this, we can hide it. Or we can make it more explicit. Get rid of the text part here. Hmm? Mm-mm. What do we think type name is? Oh, we probably don't need the cons there. That's probably what that was. I was just copy pasting in my brain. Okay. A little better. So we're making a little further in the parse. Now we're failing on unexpected 2. We might have the same thing here. And we could probably be a little bit more cute with this, since we don't really need to bind digits. And that should be good to go. Okay. Almost. So verbs. Verbs is failing. Which verbs is failing? Line 9. So the empty verbs. We're not going to... Yeah, we said we're going to leave verbs out for now. So we'll just get rid of that. Not bother parsing it. Because we took that out. That's right. Okay, so it worked. And let's just double verify, double check, triple check. Hardcore. As we're almost out of time for tonight, so let's just wrap this up, yeah. So we're gonna exec the adventure maker on the data build example, no, example adventure. We're going to pop over there, unzip the game.zip file. Oh. The build directory. Unzip the game.zip file. And we're going to replace it, yep. I'm going to open world.json. And there's our objects. All right. Baz and bar. Game object description. It looks a little rubbery and wet. And a long steel bar. Sweet. Yeah, let's kill that buffer at least. Yeah, we're stuck here. There we go. Okay, and we'll commit that. So we added the game objects section parser to Adventure Maker. The author can now define basic game object items. Sweet. So yeah, next we have to implement containers and parse those, which should be pretty straightforward now. And well, except for the locks. The locks might be a little bit tricky. We might need a special syntax for that. But yeah, then we have the game objects section parsing, which is great. So if you're looking for this code that we've just worked on tonight, it's under github.com under Agent Ultra. That's me. Adventure Engine. All right. It's not protecting from force pushing. Oh no. And there you go. So you can check it out there. You can fork, star, whatever you like. And yeah. So if you're tuning in for the first time, you haven't seen the stream before, I do these about once a week on Tuesday evenings around 10 after 8 in the Eastern Daylight Time, saving time zones, whatever time zone we're in now. And we mostly do Haskell programming, so tune in. If you're on the Twitches, of course, give us a subscribe. I love subscriptions, subscribers, and followers and stuff. And you'll get notified when I go online. Sometimes I do kind of pop up and do random stuff every now and again. And you'll get notified of those when I go online. If you're on YouTube, you know what to do there. Of course, subscribe, like, smash a thing, all that stuff. And we'll see you next week. May all your monads be free. May your types always check. And happy hacking. See ya.